Welcome back to part 3, how I built my pole barn shop. The next step in my journey was to have a septic system installed for the bathroom. For my purposes, a buried 50-gallon drum and a field line would have been sufficient. And more than a few people suggested I do just that and not get a permit. However, I wanted to meet code and not have it come back to bite me down the road. So in the end, I complied with the health department, installed this full-blown outlay, and parted with over $5,000. It seemed like the county was envisioning a shop with 10 workers in daily use rather than a solitary homeowner using it sparingly. In any event, I did as told, hired a local contractor to do the install, and was very pleased with their work. One thing I always try to do is document with pictures, especially things that are going to be buried underground. A year from now, 5 years from now, I'm not going to remember what things look like or exactly where they were buried. So I like to take a photo and then superimpose distances from known sources, like you see in this picture. Having visual documentation has saved my hide on more than one occasion. Once the septic system, buried water line, and French drain were installed, I was ready to turn my attention to outside wall sheet metal. As you can see in this picture, I had already finished closing in the gable ends by this point. Since they required work at height while standing on my truck flatbed scaffolding, it was labor intensive and somewhat time consuming going up and down ladders. Now I began installing wall sheet metal. At this point in life, speed is controlled by an internal governor of which folks my age have little control. I was able to cut, place, and screw about 2, 3, and perhaps sometimes 4 panels per day on the wall. Part of the reason it took longer is that I did not spare screws. On average, about 80 screws were used on each and every vertical side panel. Whenever a horizontal board was located behind the sheet metal, a screw was placed on each and every side of all ribs. A lot of builders only use 1 screw per rib, and perhaps that's even the recommended. But I was raised to over-engineer everything. If I get a windstorm, I wanted to give those sheet metal panels every possible chance to survive. Some of you may be wondering where the sheet metal came from. The metal had previously been removed from a chicken barn being torn down about 20 miles from where I live. For 3 or 4 years, I purposely allowed the panels to lay flat on top of each other outside in the elements. When it would rain, the water would collect on each panel, and slowly the galvanized metal surface began to rust a bit, giving it this look. I did that because I wanted the shop to have a vintage look on the outside while being new on the inside. The outside reminds me of my childhood when barns looked like this, and from a distance it almost looks like aged vertical wood, which is exactly what I was hoping for. For those who've seen the shop in person, the question almost always comes up, where did I get sheet metal that looks like that? As you can see, at this point the west end wall was now entirely finished with 3 panels attached to the north wall as well. Note also the pink 1.5-inch board insulation that I had begun to install in the walls from the inside. The reason my green terramite is beside the shop was because I would raise the bucket and use it as a standing surface to attach screws up high. At this point, I'm going to digress for a moment and talk about the attic. In this photo, you can see the walkway I constructed from one end of the shop to the other. I did that because I knew there would be times I needed to work up there. Maybe run additional electric lines or water lines or whatever. And for that reason, I didn't want to be forced to navigate between trusses that were 4 foot apart. So I built this gangway. In addition, I later added these 3/4-inch plywood gussets at stress points on the trusses. Initially, I didn't plan to have sheet metal inside on the ceiling. And when I decided to do that, I felt that that extra weight I should probably account for and beef up the trusses. This is the view looking at the gangway from above by the access door. If you look closely, you can see the attic lights. There are 9 attic light locations, and here is a schematic showing them. Besides the attic lights, there are 5 strategic outlets installed as well. The result is that any time I or a future owner might have to access or work up in the attic, there is plenty of light, there's access to electricity, and a gangway to navigate from one end of the building to the other. In addition, I keep 3 or 4 5-foot long 2x12s in the attic to place between trusses if I ever have to work either side of the gangway. This open air view is one I will always cherish. And the reason is simple. It's because I absolutely loved having this open air place to work. I had a roof over my head. I was out of the direct sun. If it was raining, it wasn't an issue. Often there would be a breeze blowing. The nearby birds would be singing, and it was just a pleasure to have this open. Consequently, I did everything I could to do any other job around the shop and keep this north side open as long as possible. Eventually, I knew it was going to be closed, but I sure did enjoy it while I could. I'd like to shift gears once again and talk about insulation. It's an extremely important component to my shop and to the enjoyment of working in the shop. What you see here are over 200 insulation boards, each 1.5 inches thick by 4 feet wide by 20 feet long. Each board thickness is rated an R7.5 value. On average, my shop walls and ceiling are covered with 4 layers thick of insulation boards. Along with a vapor barrier, inside and outside sheet metal, that means the building is insulated to nearly an R30 value. The result is that on a hot summer day like yesterday, it was in the 90s, it was 69 degrees inside. The other day I had somebody come by the shop. They walked in and they said, "Oh my goodness, you got this place air conditioned." It's not air conditioned, it's just well insulated. This is the southwest corner of the shop where the bathroom will be located. You can see the vent pipe going up through the wall, along with the water PEX line and drain pipe below. The ceiling hole above it is the access door into the attic. What you see on the ceiling is a layer of plastic held in place by 1.5 inch galvanized metal strips about 20 gauge thick. Above that is where the insulation boards are cut to fit between the truss bottoms. Here you can see the progression of how the plastic was attached to the ceiling. I purchased this sheetrock lift used, added an 18-inch homemade extension to reach my 13-foot ceiling height, and then added the 2x4 on top. I would first drape the plastic over the 2x4, lift it up, then staple one side of the plastic into the ceiling trusses. Then I'd move the lift over a couple feet from the wall to the position you see here. Then I placed one end of a galvanized strip on the first truss and nailed it. Then simply moved over to the next truss and nailed it. Once that first strip was in place, I could then move the lift over another 2 feet and repeat the process. As I would do each 4 feet or so, I'd cut and place 3 to 4 layers of insulation on top between the trusses. Then the whole process was repeated over and over. Once the southern half of the ceiling had plastic and insulation, I decided to begin installing ceiling metal. For the inside metal, I chose new white sheet metal. I wanted to create a bright working environment. In this photo, you can see the first ceiling piece raised into place. I used the sheetrock lift and built a rectangular wood 2x4 frame on top, and that held the metal, as you can see. Each metal piece was about 3 feet wide by about a little over 13 feet long. It was a fairly simple process, really. I'd position the metal on top of the wood frame and crank it up into place. And once there, I would climb a ladder and screw it into place. The first course of ceiling panels went up rather easily. Really, I was surprised because I had never put up ceiling pieces like that and I didn't know what to expect, especially since I was doing it on my own. Anyway, the first course went well. I suppose I could put up about 3 or 4 panels a day. It was when I was about halfway through the second course that I encountered a problem. As you can see in this picture, the end of one piece accidentally got contorted. Here are 3 pictures side by side which show the contortion from different angles. As you can see, it was rather severe and certainly would not pass muster on my inspection. The reason it got contorted was my own fault. It was because I got in a hurry. Instead of placing one screw at the end where it was matching the last piece placed, and then moving to the other end, I instead screwed that entire first end in place. That then set the orientation for the whole piece lengthwise, and unfortunately it was not quite matching at the other end. Then I continued screwing down the panel towards that other end, and by the time I got to the other end, the contortion became apparent. Fortunately, it turned out to be an easy fix. I simply removed all the screws except one where it matched the last piece. Unfortunately, at that point, the sheet metal contortion disappeared and went back to its original shape. Then I went to the other end, matched it up with the side panel beside it, and placed a screw. Now the panel was in its correct orientation. Then I could randomly finish rescrewing it. As long as I placed one screw on one end, then went to the other end and placed a screw there so it was set in place, then randomly filled in the rest, it all worked fine. The first two courses of ceiling panels went up within a relatively short period of time. And that was because there was no need to fit pieces. There was no need to cut holes in the panels to fit around something. It was just a matter of screwing up one panel in place and then screwing up the next panel end to end. However, with the third course and most of the rest of the ceiling thereafter, everything slowed down just a bit. The reason was because it was then I began to encounter the ceiling electrical box locations that were already previously wired and roughed in. If you look at this schematic, it shows where the electrical boxes ended up being placed. There are 2 rows of LED lights with 8 boxes needed to power the 8 LED bulbs. Then there's 2 rows of ceiling fans with 8 additional boxes to power those. And lastly, there are 4 banks of fluorescent lights, each bank having 6 4-foot-long fluorescent fixtures with 6 bulbs each. That was another 12 electrical boxes. Not including the bathroom, that means there were 28 ceiling electrical box holes that had to be dealt with while installing ceiling panels. So briefly, here's what occurred when I would encounter a box location or a wire location. The first thing was to mark on the next panel to be raised exactly where those wires would be coming through that panel. That was reasonably simple because all I had to do was take a measurement from 2 known perpendicular points on the ceiling to the wire and then transpose that information to the new panel. So my first measurement was from the edge of the last panel installed to where the wire was going to come through. Then I would add 3 inches. Why 3 inches? Because when I would raise up a new panel, once it was up there, I'd slide it back 3 inches under the lip of the previous panel installed. In that way, there were never 2 panels butted end to end. There was always an overlap, and that makes for a very professional finished look. Then I would measure from the wire in a perpendicular line to another known point. In my case, it was generally the edge of the adjacent ceiling panel in the previous course. Once I had that information, it was just a matter of transposing it to the new panel. When the ceiling was previously roughed in with wire, I made sure to leave plenty of extra wire at each box location. That was important because that allowed me to shift the ultimate box location a few inches in any direction. This meant I could ensure that every ceiling box ended up in a straight line on the ceiling, and also that the box was always between the same panel ribs and not on a rib. Once the panel was marked where the wires would come through, I used a 1-inch knockout to create that hole. Now when the panel went up, I would just feed the wires through that hole. And that was the location I would then screw the box into the ceiling truss. In a future video, I'll be talking more about the lighting and the electrical in the shop. If you liked this video, gleaned a few ideas, and want to see how the build proceeded, Please hit the like button and go to part 4 of how I built my pole barn shop. Remember, before adopting any idea, be sure to run it by a qualified professional. And if you're contemplating a project, good luck, and thanks for watching.